Hello everyone, welcome to my channel Get Educon. Here we will discuss about GATE subjects, mainly computer science GATE subjects. So today we will discuss about operating system first chapter, which is basics of operating system. So you can see our syllabus is like that: processes, threads, inter-process communication, concurrency and synchronization, deadlocks, CPU scheduling, memory management, virtual memory, IO scheduling, file systems, system calls. These topics will be covered. Okay. So, firstly, I will discuss very basic part. So, that is computer. So, what is a computer? So, computer is a machine or electric device used to store, process the data, and produce some output with the help of that data or information. So we will do some programmings and some processes with the help of some softwares and hardwares. Okay, so there are some hardware devices and software tools. Okay, so what are the hardware devices? What hardware devices means the physical devices that we can touch, like disk, CPU, monitor, mouse, anything. And software is set of programs. Okay, this is set of programs. Now, hardware and software devices or resources. Okay, so with the combination of these hardware and software devices, computer formed. Clear? Okay, so now see this. So it is computer, and uh, the one part is hardware resource and another part is software resource. So under the hardware resource, you can see CPU, memories. Okay, CPU, memories, disk, IO devices means input output devices, printer. These are the hardware resources. And software resources, this we can divide into two parts. First one is system software devices and second one is application software devices. So what are the system software devices? Those are like assembler, compiler, loader, and operating system itself is also a system software. Okay, and what are the application softwares? Any applications we can see in our computer, those are application softwares. Okay, like ticketing system, online library management system, anything, any applications like you can see Facebook in your Android operating system, okay, or Android phone. Okay, Facebook, Instagram, YouTube, anything. These are the software application systems. Okay, so next, what is firmware? You know what is software, what is hardware. The next important thing is what is hardware. Okay, so what is firmware? Sorry. So you know the already the software and hardware. So now the new thing is firmware. So the program written in the read-only memory means ROM. So the program which is written in the read-only memory means ROM, like BIOS programs. Okay, these are the firmware. So you know this random access memory and read-only memory. This RAM and ROM is the primary memory. Okay. Now the operating system. So we now our basic part is operating system, means our key term is operating system for the subject. Okay, so you know that as I told here, in the system software, operating system is itself a system software. Okay, so operating system, it is a system software and it is the interface between the user of the computer and the computer hardware. Okay, so it makes the bridge between the user and the computer hardware. Okay, so you can see the flow here: users, then application programs, then operating systems, then computer hardware. Okay, the functionalities will start from here. User will click on the application programs like Facebook, okay, or YouTube, anything. Then it will uh, uh, ping the operating system, okay. Then means request some process to operating system. Then it will request to computer hardware, and response will be from computer hardware to operating system, and operating system to application programs, and the output will generate, and the output will be visible to users. Okay, clear? Okay. So now what is the goal of operating system? So our main goal is convenient utilizations of user resources and effective utilization of resources. Okay, like something book. What is the use of book if you not read? Okay, so our main goals are convenient utilizations of resources and effective utilizations of resources. Okay, so now the next part is user system view about operating system. So there are users view and system view. Users view means user at personal computer, user at mainframe or mini computer, and user at workstation. Okay, so in workstation maybe server is there and some clients are also there. So server client or client server architecture are there. So one server, many clients you can see here. Okay, next thing is systems view. Systems views work is this control program and resource allocation. Okay, now we will discuss about types of operating systems. There are so many types of operating systems like batch operating systems, multi-programming operating systems, multitasking operating systems, and multi-processor operating systems. Questions will come from mainly these three parts, mainly, as these three are confusing: multi-programming, multitasking, multiprocessing. I will discuss later. So next one is real-time operating system, distributed operating system, embedded operating system, personal computer systems, interactive or time sharing system. Yeah. Okay. Chalo. So batch operating system means the first one. So there are some users like user one, user two, user n, and one user will do some work like job one or job two. This is operator, and there are some batches, batch two, batch one, in this way. Like batch two means jobs with a similar need group together. Like job 7, job 5, and job 2 are similar types of jobs. So these are under batch 2, and job 4, job 1, suppose similar types of jobs. So these two are grouped together in the batch 1. So after completion of these, you can see here CPU plus OS plus user program. This is the complete process for the batch operating system. Next one is multi-programmed operating system. So here one main memory is there, okay, and several jobs or several programs will run in this operating system. And in case of monoprogram, means monoprogramming, there one main memory and or one operating system, one job. Okay, but here max memory layout for multi-programming system. What are the disadvantages in the monoprogramming, for which we switched from monoprogramming to multiprogramming? Why we switch monoprogramming to multiprogramming? As there are some disadvantages in monoprogramming. We cannot use CPU effectively. CPU executes only if the program is in the main memory. So monoprogramming is only one process at a time. Okay. So sometimes CPU time is required for the job which is called a CPU burst. Sometimes IO time is required for a job which is called as IO burst. And here CPU burst and IO burst will do some clockwise process, like one CPU burst, then IO burst in loop, then again CPU burst. Not the same, but another CPU burst, then again IO burst, then again CPU burst. like this way: CPU burst, IO burst, okay, then again CPU burst, then again IO burst, in this way. So when process is doing IO activity, CPU remains idle as only job in the memory. So no job will process in the CPU. But in case of multi-programming systems, or means this in this case, multi-programming systems, when one job is doing IO activity, the next job will do the CPU activity. So it's use the CPU time. So advantage is that in that case we can utilize CPU effectively. CPU does not remain idle for long time. Okay, so this is the advantage of the multi-programming operating system over monoprogramming. क्लियर? ये तो क्लियर होना चाहिए क्योंकि means this multi-programming operating systems is very much advanced from monoprogramming, and so we switched from monoprogramming to multi-programming. Okay. So next one is multitasking operating system. But you have to remember that in the multitasking operating system, only CPU is there for multitasking. Okay. Multi-programming with user interface is known as the multitasking. This one is very much important. This line. Multi-programming with user interaction is known as multitasking. Okay. Multi-programming with user interaction is known as the multitasking. Clear? So here, like some word processor means multitasks are going simultaneously. Like word processor processed, email processed, web browser, antivirus process. Okay, one operating system and one CPU core. So one CPU is there. Okay, so multi-programming is done in the mainframe computer, and multitasking is done in normal computer or personal computer. But for utilization and effectiveness, both multitasking and multi-programming are same. Next one is multiprocessor operating system. Here multi-CPU will be there. For multitasking, one CPU is there. For multiprocessor operating system, देखो multiprocessor, CPU means central processing unit, P for processing. So multiprocessor means multiprocessing unit will be there. Okay, like here word processor and email, these processes are done by CPU core 1, CPU 1, and suppose web browser and antivirus, these processes are done by CPU core CPU 2. Okay, so what are the features of this multi-processor operating system? Tightly coupled operating system, okay, common memory and common clock parallel systems. Okay, common memory and common clock, tightly coupled systems and parallel systems. Okay, so like CPU 1 will do job 1, CPU 2 will do job 2, CPU 3 will do job 3, CPU n will do job n, in this way. And here it is the main memory. Next one is real-time operating system. What is real-time operating system? A real-time operating system, basically a system which functions under strict time constraints. This is called as the real-time operating systems. Strict time constraints. This is the important part. So if time constraints are not followed, then systems will fail. Okay. So first one is hard real-time system, means where time constant is too rigid, and soft real-time systems where time constant is not so rigid. Okay, so some examples are like hard real-time systems, weapon control systems, patients medical imaging systems, underground tank monitoring system. Soft real-time systems are multimedia planetary systems. Okay, multimedia planetary rover systems. And next one is distributed operating system. This is called as loosely coupled. Here it is called as tightly coupled, which is multiprocessor operating system. Okay, multiprocessor operating system is tightly coupled system, and distributed operating system is loosely coupled. coupled system. Okay, every computer will have its own memory and clock. Okay, but here you can see in multiprocessor common memory and common clock. Okay, and as each each computer will have its own memory and clock, so this is flexible, so this is loosely coupled. Okay, so distributed operating systems can be in local area network, MAN, or wide area network, Okay, so uh, this is like high speed buses or telephone line. Distributed environment can be localized or globalized. Okay, localized, so we can use it in local area network, and we can use it globalized, so wide area network. So main features are it share the resources and get the service faster, and also it can be helpful for process migration, computation migration, and file replication. Next, user and kernel. So computer is operating in user mode and kernel mode simultaneously. User mode means user program is executing, and kernel mode means operating system code is executing. Okay, user mode, user process executing, then it gets the system calls, then trap and mode bit equals to 0, means change its bits. When it will change its bits to 0, then it will go from user bit to kernel bit, and when it when the mode bit will change to 1, then it will go to the user mode. Okay, so in user mode bit is 1, in kernel mode bit is 0. Okay, so user process executing, then get system call. After that, it trap and mode bit sets to 0, then execute the system call, and after that again transfer the mode bit to 1, then return from the system call. Okay, this is the architecture of that. So user to kernel mode and kernel to user mode. Next one is kernel mode. The another names are monitor mode, privileged mode, supervised mode, system mode. Okay, so various examples of this privileged instruction includes IO instructions and halt instructions, turn off all interrupts, set the timer, context switching, and clear the memory or remove a process from the memory. Clear? And modify the entries in device status table. And user mode functionalities are various examples of non-privileged instructions include reading the status of processor. Okay, and then reading the system time, generate any trap instruction, sending the final printout of printer. Then the time sharing system. Time sharing system, we will use it in a round robin CPU scheduling. Okay, we will later discuss it. But what it is, means time sharing system is where CPU time is equally shared. Okay, like you can like there will be some time quantum. Okay, in a round robin time quantum, suppose 2 milliseconds. Okay, so suppose job 1, it will suppose its burst time or CPU utilization time is suppose 8 millisecond. Okay, but in one time it will not able to use it more than 2 millisecond most. Like suppose job 1 8 millisecond burst time, job 2 suppose 10 millisecond burst time, job 3 suppose 3 millisecond burst time. Suppose its arrival time is 0. Suppose its arrival time is here I use the simple thing, like simple example, like here 0 2 and it's suppose 4. Okay, so here job 1, like you can use the Gantt chart like here. So job 1, it can use 0 to 2. In time 2, job 2 arrives, so then job 2 will do up to 4, then job 3 job 3, then it will do up to 6, then again job 1 again 8, then again job 2, 10, in this way. Okay, in this way. Okay, now next is a system call. It is a software interrupt, and there are so many types of system calls like process management system call, memory management system call, file management system call, device management system call. Something creates, okay, okay, some create function, then system mode, then system call. This is called the software interrupts. Okay, the process cannot be executed here. So after that, you can see types of system calls like process control, uh, end about, load execute, create process, terminate process, in this way. Next one is file management system calls. Next one is device management system calls. We will discuss these things later. So stay tuned and do like, share, subscribe to our channel if you like it. Okay. So next we will discuss about process management and CPU scheduling parts. Okay, bye.